17.7 is volume with known cross-section on the x-axis. So we've done area. Now we're going to expand it to do volume. So we're talking about three-dimensional things. It says, let the region R be the area enclosed by the function f of x equals 2x cubed and g of x equals 2x. Region R is the base of a solid such that each cross-section, so each little slice, is perpendicular to the x-axis, makes a square. So this is telling us our shape we're dealing with. Find the volume of such solid. Use a calculator round to the nearest thousand. So this is the picture that they'll give you. We need to find the volume that would consist all in here. And so now it's really hard to imagine a three-dimensional shape coming out of that. So I went ahead and included the picture on, like, once you submit your answer, it'll show you this and it'll have a slider. So what that does is, see these squares here, and the squares created by this top function minus this bottom function here. That's one side of the square, and then it kind of pops up out of the page. And if you hit the slider or slide it, it'll create square, 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 all the way to stop to here. But I'm not going to draw it because that probably will make it worse. But if you go to that, it'll definitely help you visualize what I'm talking about. So what I'd like to do is just make a square where I know all sides are the same. So if I want to find area of a square, it's side times side, or the side squared. Well, how do I find one of the sides? Well, I just said it. We're going to take top line minus bottom line, just like how we found area of a function on the previous, or 2 lessons ago. So we want to do top line minus bottom line. And that was linear, which was g of x is on top, f of x is on bottom. So think about the side, I'm going to do s, equals g of x minus f of x. Okay, so then I'm going to antiderive that. So this kind of helps me think of, if I am taking the antiderivative of a function, like I did 2 lessons ago, that got me area. Well, if I can antiderive area, that actually gets me volume. So I want to take the antiderivative, and I'll have to find this point of intersection here. I'm sure this is probably 0 here. But if I could find those, that'll give me my lower and upper bounds. And then I'm going to do the area of a square, which is the side times the side. So this is one side. Well, then I'm going to have to square that to make that be my area. So area of the square is going to be g of x minus f of x quantity squared dx. So go ahead and find these 2 points of intersection here so we can have our lower and upper bounds. And I did find this to be 0, 0, and this is the point 1, comma 2. I had to zoom in a little bit so I could see them. So let's go ahead and add in our x values. We're going from 0 to 1. We're accumulating all of the area between the top line and the bottom line. So then I'm going to get out of that. I'm going to go math 9, 0 to 1. And then g of x I know is really my y2, and this is my y1. Or more simply might just be to take g of x, which is 2x minus 2x cubed. Okay, well, I didn't need to distribute all that, did I? So I could do, but you're going to want to do another parentheses because then that's going to get squared. So I'm going to do 2x minus 2x cubed, close parentheses, squared on the outside again. And then because this gives us a side, well, to find area, we're taking side squared dx. And that will accumulate to the volume, which it's pretty small because this actually is not very big shape. So volume is 0.305. All right, let's try one more. We've got f of x equals 2, so y equals 2, that's a horizontal line here. Did I not include the right picture? That should be what? Let's just say that it's 2x cubed. I think that got messed up because this looks like a cubic function to me, but I do have the horizontal line y equals -3, so I know that is right. And then we've got x equals 0 and x equals 2. So I already know my lower and upper bounds here. And I'm trying to find the volume, and it's making a rectangle whose height is half the length of its base. Find the volume of the solid. So if you can see it on here, there's rectangles coming out off the page, and this is the length of it. So let's draw a rectangle. So the length of it from here to here is going to be upper function minus lower function. And so upper function is the 2x cubed, or f of x. So this is going to be f of x minus g, nope, not even really g, minus -3, because that's where our y equals line goes to. So that'll really be +3. I might just go ahead and say that's 2x cubed plus 3 to simplify it. Okay, and then to find the height is what they're calling it. To me, that's kind of a width, but because it's jumping off the page, I guess it is how tall it is. It says it's half the length of its base, so we would have half of that. So this is height, this is base, or length and width. Okay, so then we're ready to integrate it. So we're going to say volume is going to be equal to the integral. We're going from x values of 0 to 2. And then how could I simplify this to put on my calculator? Well, if I'm having a half times 2x cubed plus 3 times another 2x cubed plus 3, right? Length times width. I can really have a half times this squared. Dx. Okay, so I actually don't need to put anything into my y equals. I'm ready to just plug this in. Math 9, 0 to 2. I'm going to put 0.5, and then I'm going to do parentheses. 2x cubed plus 3 parentheses squared with respect to x. And that'll accumulate all the volume, which is 69.571. So my advice is draw a shape, figure out the dimensions because you're trying to integrate area. So just figure out how to find area of the shape. If you need a length, you do top function minus bottom function.